Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Hope you all are doing well. This is your chemistry lesson, and in today's lesson, we'll revise the concept of mole and also we'll learn that how we can calculate the number of moles in ionic compounds. Right? We have seen that how we can find out the number of particles in molecular compounds, but today we'll learn that how the number of moles, the number of particles in different number of moles of ionic compounds can be calculated, right? First we'll revise the concept of mole. You know that mole is a unit that we use in chemistry to calculate the number of particles, because we cannot calculate the atoms in grams, in milligrams, in dozens, or in pairs. So we use a unit, we call it mole, and 1 mole is equal to 6.022 multiply 10 raised to power 23 atoms, molecules, or particles. This number is called Avogadro's number, and the number of particles can be atoms, molecules, ions, or it can be anything, right? So 1 mole is equal to this value. For 2 moles you have to multiply this value with 2. For 3 moles you have to multiply with 3, and when there are 8 moles of any substance and you have to find out the number of particles in 8 mole of that substance, then you will simply multiply the Avogadro's number to 8. Clear? Next is number of moles in different substances. First, we'll revise the definition, then we'll discuss the examples. A mole can be defined as amount of substance that contains the same number of atoms or molecules or particles as there are atoms in 12 gram of carbon 12. As you know, carbon 12 is taken as standard. So we are discussing about relative atomic mass. We are taking carbon as standard. We are discussing the number of particles. We are taking carbon as standard. Carbon 12. There are 3 isotopes of carbon and we are taking carbon 12 as standard. So it means that same number of atoms or molecules or particles, that if you are considering any substance, 1 mole of any substance, if you have to find out the number of particles in 1 mole of any substance, that number of particles is always equal to the number of particles in 1 mole of carbon 12. You know that carbon has the atomic mass of 12. So if we say that number of particles in 1 mole of sodium, if you have to calculate in 1 mole of sodium, it is equal to 1 mole of carbon. And what is the number of particles that are present in 1 mole? It is 6 multiply 10 raised to power 23. Clear? So the number of particles, number of atoms, or number of molecules in any substance is same as there are in 12 gram of carbon 12, right? So let's consider the examples of different substances. 1 mole of pure gold, what will be the number of particles? 1 mole of pure water. What is the formula of gold? What is this chemical symbol? It's AU. The chemical symbol is AU. And when we consider the relative atomic mass of gold, it is 196. Relative atomic mass is 196, but in 1 mole, the number of atoms are 6 multiplied 10 raised to power 23, right? So let's compare gold with 1 mole of pure water. What is the molecular mass of water? It is 18. Formula of water is H2O. 2 plus 16, it is 18. But in 1 mole of pure water, number of particle is again same. Number of molecule is again same as that in gold. 1 mole of hydrogen. What is the chemical symbol of hydrogen? H2. Hydrogen is a diatomic molecule. In 1 mole of hydrogen, again the number of particles are same, but the atomic mass of hydrogen is 2, right? Copper sulfate, CuSO4, number of particles are again same, but relative molecular mass will be different. Clear? So these are some of the examples that you can consider, and you can compare the number of particles in different moles of different substances. Same number of moles, same number of particles. Different number of moles, different number of particles. You just have to multiply the Avogadro's number with the respective number of the moles that you are dealing. Right? You can consider the example. Let's say for the formation of water, reaction is H2 plus O2. It will give us H2O. You have to balance the equation and you will get this. Now according to the balanced chemical equation, 2 moles of hydrogen are reacting with 1 mole of oxygen to produce 2 moles of water. 2 moles of hydrogen, you have to multiply it with this value with 2. You will multiply with 2, and for oxygen the number will remain same. 2 moles of water, you again multiply the Avogadro's number with 2, and you will get the values or the number of particles in different number of moles of respective elements or molecules that you are dealing. Right? So according to this example, 2 moles of hydrogen will react with 1 mole of oxygen to produce 2 moles of water. And you know about mole. How you can define mole? Mole is the amount of any substance that contains the same number of atoms, molecules or particles as there are atoms in 12 gram of carbon 12. Okay? Use of Avogadro's number. The value that we have discussed before, 6 multiply. This value is called Avogadro's number. In real life, if you want to use the Avogadro's number, it's a bit weird. So mostly a chemist, when dealing with atoms, molecules, or any number of particles, we use the Avogadro's number. Because in real life, if you want to use the Avogadro's number, the value is very high. So mostly in daily life we use the units like kilograms, dozens, or we can use a pair of shoes, right? But when a chemist deal with atoms, if you are carrying out any reaction, so you have to deal with molecules, atoms, or electrons, ions, or any other particle. So we'll use the Avogadro's number for our convenience, because it is very hard for a chemist to use the units like kilogram or milligram if they are dealing with atoms or molecules, right? So Avogadro's number for same number of moles of different elements is same, but atomic mass for different elements is always different. If the number of mole is same for different elements, the number of particles will be same, but for different elements, the atomic mass is different, because when we are dealing those substances in moles, it means we are dealing them in Avogadro's number. And for 1 mole, the Avogadro's number is always same. But about relative atomic masses, it is different. For pure gold, the relative atomic mass is 196. For carbon, it is 12. So the relative atomic mass for these two substances is not same, right? Same number of moles will have same number of particles. 1 mole of gold, silver and copper will have same number of particles, but they will have their respective atomic masses. The atomic mass of gold is 197, for silver it is 108, and for copper it is 64. Atomic masses are different, but number of particles will be same. So molar mass, we have seen in previous lecture that molar mass for molecular substances is the same as of their molecular mass, but the formula mass is also same, but when you calculate the number of moles in an ionic compound, it is a little different. We'll see that how we can calculate the number of moles in an ionic compound. Clear? So the formula mass for ionic compound and molar mass for ionic compound is same. The sodium chloride formula mass is 58.55 and molar mass is same. For potassium carbonate, calcium bromide and ammonium sulfate, it's same as the formula mass or the molar mass is same. But when you have to calculate the number of particles, you have to consider the charge on the ionic compound. The ions you are dealing, like the positive ion and the negative ion, cations and anions. So in case of calcium bromide, as you can see here, the charge on calcium is +2. So it means 1 mole of calcium ion is equal to this one. For bromine, there are how many atoms of bromine? 2. -1 charge and 2 atoms of bromine. So the number of atoms that are present in compound, you will multiply that number of atoms with Avogadro's number. In molecular compounds, we have simply seen that if there is a compound HCl, it doesn't matter how many number of atoms are there, but you will simply say that it contains the Avogadro's number because it is 1 mole. But in case of ionic compounds, you have to consider the number of atoms. Calcium, 1 atom. Bromine, there are 2 atoms, 2 + 1, so it is totally equal to 3. So you will add all the values, 6 and 2 multiply these numbers, and you will get the final answer. It's 18 multiply 10 raised to power 23. This is how you calculate the number of atoms in an ionic compound. Clear? It's all for you today's lesson. Allah Hafiz.